Hello everybody, my name is Teacher Gordon and I come from Australia, and today's lesson is changing the state of matter. Okay, first of all, what is matter? Can anybody tell me what is matter? Anybody? Okay, I'll help you a little bit. Matter is anything you can see, you can touch, or you can feel. Everything in the whole universe is made of matter. The sun is made of matter. The moon is made of matter. The planet Earth is made of matter. I am made of matter. Everything is made of matter. The screen is made of matter. The air conditioner, the table, my pointer, my tie, my glasses, everything is made from matter. Okay? So we can change the states of matter through using heat or cool or cold. Okay, let's just watch a video for a minute, okay, about the changing of the state of matter. Okay, first of all, First of all, who can tell me what do we have here? What is this? Can anybody tell me? Correct, it's a glass. And what do we have inside the glass? Correct, we have ice. Okay, the glass is matter, the ice is matter. And we are going to change the state of the ice, okay? Then I will have a couple of questions for you. So let's have a look. Okay, as you can see, the ice is melting. It is changing from a solid to a liquid. Okay? Oh, makes me thirsty. Okay, good job. Oh, look at the ice. It's nearly gone, it's nearly gone. Okay, so there we see ice changing from a solid to a liquid. Okay? Now let's have a look. I've got a couple of questions I want to ask you. Alright, number one. Why is the ice melting? Can anybody tell me why is the ice melting? Very good. Because it is getting hot. It is warming up. Okay? Where does the heat that melt the ice come from? Want to tell me? Yes, very good. It comes from the air. The surrounding environment, from the sun, from the air. When we are preventing means to stop, okay? When we are stopping the ice from melting, are we preventing, again there's that word preventing, stopping, the heat from reaching the ice? Okay, so we don't want the ice to melt anymore. So what do we have to do? Correct. We have to stop the heat from getting to the ice. Okay? And how do we keep the water cold? How do we keep the water cold? Okay, there's a couple of things we can do. We can put it in a cool room. We can put it in the refrigerator. We can put it in the shade under a lovely big tree. But the main thing is to get the ice away from the source of heat. Okay? Alright, very good. You're doing a great job so far, everybody. Nice. So let's have a look at a PowerPoint here. This is from your books. There will be exercises for this PowerPoint on pages 53, 54 and 55. Exercises 1 and 2. Okay, so everybody open your books. Okay, so we have some big words, don't we, in here. So let's all go together. Everybody after me. Thermal, expansion, and contraction of matter. Okay, we all know what matter is. Matter is everything. Thermal means hot, heat. Okay. Expansion, get big, to get bigger. Contraction, to make smaller, to get smaller. Okay. Here we have these things called molecules. Everything is made up of these little tiny things called molecules. They're very, very small. You cannot see them with your eye. You need a very strong microscope. Okay, so let's go. We've got cold and hot. Okay, so everybody, let's read this together. Everyone, big voice, nice and loud. When the molecules are heated, they gain energy and vibrate or move more vigorously. Vigorously means very energetic. Vigorously, okay? And further. So they move quickly and further. Okay? This will increase the volume of the matter. What that means is it'll make the matter bigger. Thus, the matter expands. There we go, there's that word expand. Remember, expand, make big. Okay? As you can see here, we have molecules. They are cold. Same like you when you're cold. You're all close and tight and trying to keep warm. But when we heat molecules, then they vibrate and they expand. They get bigger and bigger. Same like you when it's hot. When it's hot, you're not like this, are you? When you're hot, you're like, you expand. Okay? So that is what they do. Molecules, cold, tight, and cold. When heated, loose and vibrating and get bigger. Okay, good job. Here is an example we have. Okay, everybody reading again with me. 1, 2, 3. When the air is heated, the molecules get more energy and begin to move faster and further. Okay, faster and further, expand. This takes up more space and thus the air expands. Remember expand? Get bigger. Here we have an example. Cool. The air in a bottle is cool. Okay, the molecules are all tight. Then you put a fire, we heat the air. So then the molecules start vibrating and expanding, getting bigger and bigger, and they have nowhere to go. So they go into the balloon, which makes the balloon inflate. Okay? Next slide. Okay. Most matter contracts when cool. Alright, this is like the previous slide, but in reverse this time. Now we have the hot molecules vibrating and expanding and getting bigger, and we're going to cool them down. So they will come together, they will contract, they will get smaller. Okay? So everybody, let's read again. When the molecules are cool, they lose energy and vibrate or move lesser. Okay? They're not so much. They're getting cold, they all want to come together, get warm. This will reduce means small, the volume of the matter. Thus, the matter contracts. Okay? Remember expansion, contraction. Okay, have an example, let's have a look. Okay, just like the other slide, this time it's going from hot to cold. Alright? When the air is cool, the molecules lose their energy and begin to move less. This reduces the space taken up and thus the air contracts. Okay, contracts, becomes smaller. As we can see, the molecules are hot. They fill the balloon, but then when it cools down, all the molecules come back into the bottle and contract. Okay? They're cold. They want to get in each other. Okay? Okay. Good job. Moving on. Okay. Application of thermal expansion and contraction of matter. Okay. Application. Can anybody tell me what application means? No, it's okay, no problem. I'll help you. Application is meaning how can we apply the expansion and the contraction? Okay? How can we use it? Okay? Here we have the thermometer. Okay, it's an old thermometer. Okay, we have mercury inside the thermometer. Okay? Mercury is a metal, a liquid metal. Alright, so we'll have a look here. Everybody reading with me? Alright, ready? 1, 2, 3. Mercury expands and contracts evenly with the changes in the temperature. This makes mercury suitable to be used in thermometers to measure temperature. Okay? Mercury always expands and contracts at the same rate. That is why we always use mercury for thermometers. Okay, it doesn't matter if this thermometer is in Australia or it's in Thailand, it's still going to expand and contract exactly the same, no matter what the temperature. Okay, so there's one way we can use expansion and contraction of matter. Can anybody think of any other ways? Okay, don't worry, we have some examples for you. Okay, let's have a look at the next slide. Okay, I want you to put your thinking hats on now. Okay, this is another application. Okay, different metals expand at different rates. Okay, so you might have, we have here steel and brass. Brass expands faster than steel. Alright? So let's have a look. We've got that, it's not heated, it's cool, it's just sitting there, relaxing, having a good time. Then we heat it, and then because the brass is heated quicker than the steel, the brass bends, okay? Bends up. Okay? When bimetallic, okay, bi means two, okay? Metallic means metal. So we have bimetallic, two metals. Okay? Strip of brass and steel is heated, it will bend. Yeah, bend on it, go, whoa. Okay. And we can use this in applications. Can't we? We can use this in your everyday life. You use this. You maybe don't know, you do. We'll show you. Okay. This, okay, is called a switch, okay, for an electric current. But let's go through this first, then I will explain it. Okay, everybody? Let's reading together. 1, 2, 3. Bimetallic strips are used as thermostats in some electrical appliances. A thermostat is a device that controls and maintains its temperature by breaking or completing the electrical circuit. Okay, so we have an electrical circuit here. Let's have a look. Okay, contact point, support point. This is the brass and the steel. So we have electricity coming in. It's a complete circuit. Okay, it's a complete circuit. But when this gets to a certain temperature, what does it do? It bends, doesn't it? It bends. Then it breaks the circuit. Okay, and the appliance will turn off. Okay, but then when it cools, it goes back down and completes the circuit again. Then the appliance will turn on again. Okay, can anybody give me an example of an appliance that uses this kind of thermostat? Okay, no problem, no problem. I'll help you. Let's have a look. What about this? Anybody tell me, what is this? Correct, refrigerator. What about this? What's this? Microwave oven. Very good. This? Toaster. Okay, really good. What about this? Iron. Very good. And what's this? Air conditioner. Oh, I don't know if you know this one. I don't think you have it in Thailand. It's called a heater. Where I come from, in Australia, sometimes it gets very, very cold and you have to heat your house up. Okay. So let's have a look. Bimetallic strips are used as a thermostat in ovens, irons, refrigerators, air conditioners, heaters, toasters, and fire alarms. Okay, so these are some of the applications we can use bimetallic strips to use as a thermostat. Okay, there are some more examples we can use, but we will move on. Okay, this is a picture of a thermostat. Okay, this one is for a heater. If you look in your books, you will have all these. Okay, this will be in your books. Let's read through it. Bimetallic strips are used as thermometers by coiling, okay, to go around and around and around and around the long bimetallic strips. It becomes much more sensitive to small changes in temperature. Okay, so this is a thermostat for a heater. Okay, you move this 20 degrees, 30 degrees, whatever you want. Okay, and when it gets to 30 degrees, the bimetallic will open the circuit and the heater will shut off. Then if it drops down to say 25, the bimetallic switch on again. That means the heater will come back on. Alright? Doing a really good job so far, everybody. Thank you very much. Okay. Another application we can use, these are called rivets. Okay. Rivets are used to fasten, means to put together two metal plates. Can anybody think of what we could use rivets for? Very good. Aeroplanes. Aeroplanes have lots of rivets. Boats, ships have lots of rivets. Cars can have rivets. Motorbikes can have rivets. Okay. And what they do with this, okay, you put the rivet in, the rivet is hot. Okay, again, so it's expanding, it's big, it's long. All the molecules are expanding, they're vigorously bouncing around. Okay, they're moving, they're apart. Then you put it through the hole in the metal and you knock the top down. Okay. Then, when the rivet cools, what does it do when matter cools? Very good, it contracts, doesn't it? So when the rivet cools, it contracts and pulls the metal tight together. Okay, this is another way we can use expansion and contraction of matter to help us in our everyday life. Alright, a couple more examples. Okay, what is this? Anybody know? Can you tell me? Anybody recognise that? Very good. A train track. It's a train track. Why do you think in the train track they have this little gap? Well, why do you think? Okay. Very good. Because in the summertime, when it's very hot, the tracks will expand, won't they? And if you don't have the gap, they will push against each other and break. Then the train come along, the train will fall off the tracks. Okay? You might hear this when you're on the BTS next time. And you hear you're going over these. That's that noise. Okay, that's what they're there for. So when the metal expands, it has room. Okay? Okay, you're doing really good. Thank you, everyone. You're doing a great job. Same with concrete. Concrete expands. Next time you see the footpath, you're walking the footpath, you will see these joints they put in the concrete. The same thing. When it expands, when it's hot, it will have somewhere to expand to. Otherwise, it will push and crack and break. Bridge. Next time you go over a bridge, have a look for this. Again, this is so the bridge can expand and contract. Okay, cold weather, this will open. Hot weather, it will close. Okay. Alright, same with, what are these? What do we call these? There's many everywhere outside, have lots and lots. What are they? Power lines. Okay. Same theory, the power lines are not going to crack, are they? So let's have a look. Power lines are hung loosely between the pylons. This is to allow contraction of the lines during cold nights. As you can see, look, this is called sag. They are sagging. Okay? In the daytime when it's hot, sag, but nighttime, when it gets cool, they contract, don't they? Now they expand, nighttime, contract. So we have to make room for it to expand and contract. Otherwise, they're tight, they expand, snap, break, and then we have no power. and big problem. Okay. Last time, let's have a look. What do we call this? What's this, everybody? What is it? It's a bridge. Oi, good job, everybody. You're doing very well. Alright. Some metal bridges have a free end that rests on rollers. Roller. Do you know what a roller is? Rollers are like a wheel, a big wheel. This allows, what do you think a roller is going to do? What do you think that is there for? Can anybody answer me? Very good. Because during the day when it's hot, the bridge will expand. Very good, nice. And the roller will help. Okay. Then at night time when it's cold, what does it do? It's going to contract. Well, good job everyone. You did really, really well. Okay, so that will contract and expand. Okay. Does anybody have any questions? Would you like to ask me something? No? Okay then. Well, thank you all for coming to my class. And today I hope you learned something and had a good time. And I'll see you next time. Thank you very much. Bye-bye.
Oh.